everyone, this is your Kalpana here. So in this video we are going to see variable separable method from differential equations. Okay, variable separable method, which is nothing but variables are separable. Variables are separable. Okay, so the equation dy by dx equals to f of x comma y, that is function of x comma y, function of x and y, is said to be variables separable form if we can express it in the form f of x dx equals to f of y dy, which means that we will collect function of x and dx in one side and function of y dy on the other side. Okay. Now, by integrating it on both sides, we'll get integral f of x dx equals to integral g of y dy plus some arbitrary constant. Okay. So, we get this as its solution. Okay. So, what we are going to do is, we are just going to write the function of x and its differentials dx and function of y and its differential dy on the other side. One side we'll write for x and on the other side we'll write for y. Okay. After that, we'll integrate it on both sides. Finally, we'll get the solution, right? So, this is what we call it as variable separable method. Okay. So, let's see a few problems. First problem, solve dy by dx equals to x into 2 log x plus 1 divided by sine y plus y cos y. Okay, solution. So we are given the differential equation, linear equation dy by dx equals to x into 2 log x plus 1 by sine y plus y cos y, which is of the form dy by dx is equals to function of x comma y. Okay. So, we are going to write all the x terms, functions of x and dx in one side and dy on the other side. Since you are having dy in the numerator, so you'll write function of y, sine y plus y cos y, sine y plus y cos y into dy, which is equals to x into 2 log x plus 1 into dx. Okay. So this is of the form f of y dy equals to f of x dx. Okay. So now what we are going to do? We'll just integrate on both sides. Before integrating, this can be written as sine y plus y cos y into dy equals to 2x log x plus x into dx. So, this can be written as sine y dy plus y cos y dy, which is equals to 2x log x dx plus x dx. Okay. Now integrating on both sides, which implies integral sine y dy plus integral y cos y dy equals to, since 2 is constant, so I'll take it out, 2 into integral x log x dx plus integral x dx and plus some constant, arbitrary constant c. Okay. Which implies, since we have integral sin x dx, the formula of integral sin x dx is minus cos x, and integral cos x dx is sin x. Okay. Also, we'll be using integral by parts formula, since integral f of x g of x dx is equals to f of x integral g of x dx minus integral of f dash of x into g of x dx dx. Okay. So this is the integral by parts formula. Okay. So this becomes integral sin y dy minus cos y plus integral y cos y. So this is of the form f of x into g of x. So how we can choose f of x and g of x? Using EL18 rule. EL18. Inverse, logarithmic, arithmetic, trigonometric and exponential. So you are having arithmetic first and then trigonometric. So arithmetic will be f of x and trigonometric will be your g of x. So here y is your f of x and cos y is your g of x. Okay. So let's substitute. Let's use this formula. So f of x is y into integral g of x cos y into dy minus integral of f dash of x y dash into integral g of x, which is cos y into dy. Formula is in x and our term is in y, that is f of y, right? So into dy. Okay. Which is equals to, you're having 2 into integral x log x. Again, here also you have to use integral by parts formula. So you're having arithmetic first, logarithmic will be f of x and arithmetic x will be your g of x. So f of x is log x and g of x is x. Simply we have to follow this rule. Okay. Since you are having L first, that is logarithmic first, so you'll consider log x as f of x, and next you are having arithmetic, so you'll consider x as g of x. Okay. So this is equals to 2 into f of x log x into integral g of x is x dx minus integral of f dash of x, that is log x whole dash integral g of x. G of x is x dx into dx. Okay. Plus integral x dx. Since integral x dx or x power n dx is equals to x power n plus 1 by n plus 1. So then integral x dx will be x square by 2 plus constant c. Okay. This implies minus cos y plus y into, since integral cos y is sin y minus integral of derivative of y with respect to y is 1 into integral cos y is sin y to dy equals to 2 into log x integral x power n dx is equals to x power n plus 1 by n plus 1, since we are having integral x dx. So this is equals to x power. Here you are having 1 in the power. 1 plus 1 by 1 plus 1, which is equals to x square by 2. So into, you'll get x square by 2 minus integral of log x. Derivative of log x is 1 by x. Okay. 1 by x into, again you are having integral x dx, which is x square by 2 into dx. Okay. Plus x square by 2 plus c. This implies minus cos y plus y sin y minus, since integral sin x dx is equals to cos x. So integral sin y dy will be cos y equals to 2 into log x. So log x into x square by 2 will be x square by 2 into log x minus, so this x and 1x from x square gets cancelled. So finally you'll have x by 2 integral 1 by 2 into x dx. You can write it as, you can write x by 2 as 1 by 2 into x. It will be easy, right? So since 1 by 2 is constant, so you can take it outside the integral. Finally, you'll get 1 by 2 into integral x dx plus x square by 2 plus c. So this implies minus cos y plus y sin y since integral sin x is minus cos x, sorry. So you'll get integral sin y dy minus of minus cos y, minus into minus is plus cos y equals to 2 into, so now we can directly multiply the whole term with 2. So 2 into x squared by 2 into log x minus 2 into 1 by 2 into integral x dx is x squared by 2 plus x squared by 2 plus c. Okay. So 2 gets cancelled. Here also 2 gets cancelled. And here minus cos y and plus cos y gets cancelled. So finally you'll get y sin y equals to x square log x minus x square by 2 plus x square by 2 plus c. So minus x square by 2 and plus x square by 2 gets cancelled. So this implies y sin y equals to x square log x plus c. So this is our solution. This is a general solution for the given differential equation. So this completes the problem. Okay. Integral sin x dx is equals to minus cos x. Right. So we'll see another problem. Second problem. Solve dy by dx equals to e power 3x minus 2y plus x square into e power minus 2y. Solution. So given differential equation is dy by dx equals to e power 3x minus 2y plus x square into e power minus 2y. So which can be written as dy by dx is equals to exponential. We can split this exponential term. E power 3x into e power minus 2y plus x square into e power 2y. We'll just write as it is. Okay. So this becomes dy by dx is equals to, since you're having e power minus 2y on both the terms, so you can take it as common. E power minus 2y into e power 3x plus x square. Okay. So you can notice that the terms which are under brackets are of x and this of y. Okay. So we can write it as dy by e power 2y. That means we are getting all the terms. We are collecting all the y terms. Function of y and dy on left hand side. And we collect function of x and dx on right hand side plus, okay, that's it. Okay, so we know that e power minus ax. Say ax can be written as 1 by e power ax, or e power ax equals to 1 by e power minus ax. Okay. So you can write it as dy by 1 by e power 2y. So which becomes e power 2y into dy. Okay. So this becomes e power 2y into dy equals to e power 3x plus x square into dx. So now we'll integrate on both sides. Integrating. Integral e power 2y dy equals to integral e power 3x plus x square into dx plus arbitrary constant c. So this implies, since we know that integral e power ax dx equals to e power ax by a plus c, and also integral x power n dx is equals to x power n plus 1 by n plus 1 plus c. So using these formulas, we'll solve this integration. So this implies e power 2y by y equals to e power 3x. Integral e power 3x is e power 3x by 3 plus integral x square is x power 2 plus 1 by 2 plus 1, that is x cube by 3 plus constant. Okay. E power 2y by 2. You should not write y. 2. Since a constant is 2. So you have to write 2, that is constant, in the denominator. Okay. So this implies 1 by 2 into e power 2y equals to, now I'll take 3, 1 by 3 common, so I'll get 1 by 3 into e power 3x plus x cube plus 3 times c. Okay, so this implies, now we can cross multiply. 3 times exponential 2y equals to 2 times exponential 3x plus x cube plus 3c. Okay. So this gives 3 into exponential of 2y, or exponential power 2y equals to 2 into e power 3x plus 2 into x cube plus 2 3s are 6, 6c. So this is our solution. Since c is constant, 6c you're having, you can write it as c. That means you can replace 6c as c also if you wish. Okay? Or else you can just keep it as 6c. Okay? So this is the solution. This is the general solution of the given equation, the given differential equation. Okay, this completes the problem. So here 6c is constant. C is nothing but constant. 6 times c is also a constant. So you can write it as 6c or constant, which remains the same. Okay. There is nothing much difference between 6c and c. Okay. So we have seen variable separable in this video. Hope you will understand. We'll see you in the next video. Until then, bye bye.